This is section 1.4, continued from the other day. We are going to talk about one-sided intervals. So if you started your assignment 1.4 from your book, the assignment was listed on the board. The custodians erased everything from my board this weekend. It's not there anymore. I will get it for you again if you don't have it written down. But you'll see a lot of stuff in your assignment at first, especially at the beginning of the assignment about this kind of, it says minus, and it will say plus here. So all that's saying to you is that you are trying to find what's called a one-sided limit. And that just means instead of coming in from both sides to figure out what y value is a graph approaching, instead you are only finding the limit from one side, either the left side or the right side. So if you see this, see it says from the left, what do you see? Negative. You see a negative. That negative sign means that you are coming in from the left. What's it approaching? It actually is considerably easier than if you were trying to figure out the limit as you're coming in from both sides. You're coming in from what side? What y value are we approaching?
0.
All right. Well, in this case, we don't have a function or a graph, so, but good guess, Robbie. Way to go. All right. This right here. Positive, it says plus, so that means that you are coming in from the right. Now, the only confusing part about that is if you are coming in from the right, that means you are headed in a negative direction, but you are coming in from the right. You're coming in from the left, you're coming from the negative side, and you are headed in a positive side. So that plus sign there just means that you are coming in from the right. That means you start on the right and you head in. The left means you start on the left and you head in toward the point that you're trying to evaluate. Okay. An example. F of x is equal to the square root of 4 minus x squared. Go to y equals, type it in, please. Make sure that you have your parentheses in the right spot. Square root, parenthesis, 4 minus x squared. And you're going to get a graph that looks like this thing right here. It's a half of a circle. It's a semicircle. What's the radius of the circle? 2. Radius is 2 because the distance from the center of the circle to the outside is 2 units, regardless of where I'm looking. So the question here is, what is the limit of this graph as we are approaching what number? -2 from the right. So you need to know where is -2. We are approaching it from the right. Where is -2? We are approaching this x value of -2. We are coming in from the right. So when you're coming in from the right, you have to start over here and you have to head in, head in, head in. What y value are we approaching as we get closer to that x value of -2? 0. We're approaching a y value of 0. Very good. So the limit, and this is not in your notes, you're going to probably want to add this. I just left it equals. It is approaching 0. What about this one? What if we are approaching, I'm going to delete here. What if we are approaching 2? Notice it doesn't say -2 anymore. It says 2. We are approaching 2 from the, what does that mean? That means from the left. So here's your x value of 2. We are on the left side and we are headed in following the graph, What y value are we approaching? We are approaching a y value of, again, we are approaching a y value of 0. That's it. So let's say that you have your calculator in front of you, and I ask you to find the limit as x is approaching, let's say we're looking at this graph. What is the limit as x approaches +2 from the left? So if you are headed in from the left, and you remember how you can set up your table to start at a certain value and count by, you guys were counting by 0.0001s. Well, if you want to approach 2 on your calculator, you are going to probably want it to start at 2, count by 0, 0, 1, but where would you go in your table to look to see what is it approaching? Do you want to look right before 2 or right after 2 is my question. Right before, because you are coming from the left. So that means if you're coming from the left, you're looking at x values that are smaller than 2. So you're going to probably want to look at 1.999. And then if you wanted to look after it, you would get 2.001. But if we're approaching, we want to know what's happening from the left. We want to look right before the 2. Does that make sense? Okay, so remember you still have that option too. Explore things on tables if it helps also.
What if it doesn't say error on it? It's not supposed to say error.
Well, in this case it shouldn't say error because not only does the function actually exist. So you guys are so used to looking at finding errors, but you were figuring out where it was approaching. Here the function exists at that value and the limit exists. In fact, they are the same, which we're going to get to in just a minute. Okay? All right, a function is continuous on closed interval. See this right here?
Yep.
This right here. Important. See the closed interval? A comma B. What do those brackets mean? Including A and B. You okay?
Yes.
All right, so a function is continuous on closed interval a, b if it is. These 3 things need to be met. This has to be met, this has to be met, that has to be met. First of all, it has to be a continuous graph over an open interval. You see the bracket, the parentheses, not the brackets. So it has to be a continuous graph. So if you're looking at this, for example, is the graph continuous in between those points? Does it go on and on and on? Yes. So that would be an example of when a graph is continuous in between A and B. But it also has to meet these 2 stipulations, which means this. You have to be able to, the limit of the function, so this graph right here, the limit as you approach A, here's A, from the, what does that plus sign mean?
Right.
From the right. As you are approaching it from the right, that means I am heading in here, heading in from the right. I'm approaching this point. The limit would be whatever the y value is here. Is that the same as the value of this function when I plug A in? So when I put A in, I get that point. Is that point the same as the limit as I am headed in from the right? Yes. So this is also met. But now you need to check the other end. You need to check what's going on over here. You need to find the limit of the function as we approach B. Here's B. From this, which remember means left. As you are headed in and approaching this point, the limit is this value. That's the point that we are approaching. Is it the same as the value of the function at that point? So what is the value of the function at B? Well, it's that, which happens to match the limit. So all 3 of these are met, therefore it is continuous, not only at a point, but it is continuous in a certain interval. So more than 1 point. Yes?
For number 1, why is it talking about open intervals if we're talking about closed intervals? I don't get it.
They're saying in order for the closed interval to be continuous, if there was a break in this graph right here, then automatically this graph is not going to be considered over a closed interval because it's not closed over, or it's not continuous over a open interval. There's a break. You don't even have to check anything else after that. As soon as that's not true, you know it's not going to be continuous at the end points also. Or it might be continuous at the end points, but it's not considered continuous over the entire interval because we have a situation where it's not continuous. All right, I have one example. Type it into your calculator, please. square root of 1 minus x squared. I believe you get another semicircle, am I right?
Yep.
Graph looks like this. And this graph is only defined, would you guys agree? It's only defined from -1 to 1. Yes? So my question to you is this graph continuous in the entire domain? So does it continue and continue and continue through the entire, so in other words, we are talking about whether or not this function is continuous from closed interval -1 to +1. So, is it continuous on open interval? In other words, disregard the points right at -1 and 1. Just check to see, does the graph exist in between those points? Are there any breaks or holes or gaps or asymptotes that the graph is approaching? No, it's continuous. So we have met criteria 1. But now we need to check to see if we are approaching -1 from the right, so we're coming in from the right side, headed in toward -1, what is the limit as we approach that value? It is 0. Is it the same as if we were to figure out the value of the function at -1? So you go to -1, does the function exist? Is it 0 at that point? Yes, so the limit matches the value of the function at that point. So this is a true statement. These things are equal to each other. What happens if you are approaching 1 from the left? So as we're following this graph, approaching 1, approaching 1, approaching 1, is the graph, or what is the limit as we're approaching 1? Should be 0. Is it the same as finding the value of the function at 1? F of 1 is 0. So all 3 of these are met, therefore the graph is continuous on the